Não está aparecendo a imagem lá no... Pronto, estamos ao vivo. Chegamos. Boa noite, pessoal. Bem-vindos a mais um vídeo do Quarkus Clube, mais um encontro aqui com a nossa comunidade. E a gente está hoje com um assunto muito interessante. A gente vai falar do Dapr, né? A gente trouxe um dos mantenedores, né? O Maurício Salatino, Java Champion, conhecedor profundo do assunto. E ele vai estar com a gente aqui hoje, dividindo um pouco, não muito, do conhecimento dele, né? Aqui com a comunidade do Quarkus, e quem mais aí quiser assistir aí, né? Esperamos que a gente, com esse vídeo, a gente ainda tenha mais inscrições lá no nosso canal, né? Aqui lá na nossa comunidade, né? E que tudo dê certo aí. Eu vou chamar eles para o palco aqui. Opa, deixa eu ver qual que é o... Tá aí.
Ok. Vamos mudar aqui Boa noite, pessoal. Eu vou falar em português aqui de início, mas a tal que vai ser em inglês. Não sei o que vocês preferem no chat, se preferem em português ou se preferem inglês ou espanhol. Português não, porque o Maurício não consegue... acho que português não está...
I understand a little bit.
Ok. Mas vamos, acho que podemos ir deixa eu ver os comentários aqui. O Max aí, beleza. Eu acho que é melhor a gente falar em inglês. Vamos em inglês. Aqui, o Max está falando inglês. Então, let's send the language.
Let's do it in English. Let's do it in English, yeah.
Okay. Let's go.
Good stuff.
So, thanks to stay here with us in this Quarkus Club. It's an honor to have you here talking with us, talking about Dapr, about Java. Thanks a lot. Perfect.
Thank you for the invitation. Yeah.
Okay.
And we have been working together, so yeah, this is well deserved. Like we definitely need to do this together. So.
Yeah. Perfect. Let's share my screen. 1 moment. Okay, perfect.
Great. Okay, so should we get started? Yeah, let's do it.
You want to introduce yourself or talk about you?
Yeah.
I think we have slides to talk about it.
Exactly. So just for people just joining, this presentation, it's a little bit about the CNCF project that it's called Dapr, and we will be focusing specifically on Dapr and Quarkus in this presentation. I will be doing a generic introduction about the project itself, and then we will look at examples using Quarkus for like building a Java application with this project. As you might have heard, like Dapr, it's kind of like in the Cloud Native Computing Foundation, and it basically means that it's very Kubernetes heavy. So we will be talking a little bit about Java and Kubernetes as well. So can we switch to the next slide so I do kind of like a quick intro? Yes. So my name is Mauricio Salatino. I am working at the company that it's called Diagrid. This company was created specifically for this CNCF project that it's called Dapr. So I've been working with these folks for the last 3 years. I'm a Dapr maintainer. I'm also a Java champion. I did a lot of Java before joining this company and working in Kubernetes. And I'm also involved with different CNCF initiatives as part of like the tags and these groups that basically look into different aspects of the cloud native ecosystem. I also wrote the book in 2023 titled Platform Engineering on Kubernetes that's been translated to a bunch of different languages, and it has a repository with a lot of examples that you can go and check if you're interested in. Next slide. I'm also started writing a new book now in 2024 titled Developer Experience on Kubernetes. This is with someone from the Java community, another Java champion called Thomas Vitale. So if you're interested in that, also like check it out on the Manning website. And I'm here with Mateus, who is also working with me on the Dapr project.
Thanks a lot. My name is Mateus Cruz. I'm working now in Itaú. And actually, I'm contributing with Quarkus and Quarkverse. And actually, with Quarkus Dapr extension, Quarkus OpenAPI generator extension, and Java SDK too, with Mauricio. And this is my website. I'm not Java champion.
Not
but
yet.
okay, not
It's
yet.
coming.
It's coming in the future. Okay.
Yep.
Perfect.
So let's start talking about Dapr in itself, right? And why you should care as a Java developer or as a Quarkus developer on this tool, right? So Dapr, that's the name of the project. You can go to the website dapr.io. And Dapr stands for Distributed Application Runtime. And you can consider Dapr as a Kubernetes extension. That basically means that if you are running your applications on top of a Kubernetes cluster, you can install Dapr into the cluster, and you will get a bunch of new features for your applications to make your application developers' life a little bit more simpler. Dapr can be summarized as providing application level APIs to interact with other services and infrastructure to make your applications resilient and observable and secure. And this is kind of interesting because when I usually describe Dapr, it sounds very abstract. So what we wanted to do with Mateus here is to show you examples on how this works. So let's switch to the next one. There are a bunch of blog posts already about Dapr for Java developers that I wrote in the company website. So if you're interested in that, check it out and please give us feedback. The next one is also a little bit about also in the Spring community. I know this is a Quarkus meetup, but we have done a lot of work on the Spring community. And now we are going to be showing kind of all the Quarkus stuff. But there are a couple of presentations that if you're interested, just can check out on YouTube. So next one. So let's talk about Dapr. And as you can see, if you go to the website, you will see some sort of diagrams like these. That basically Dapr sits in the middle between your applications and infrastructure. In this case, we see a message broker, we see a database, and we see workflows for orchestrations. So the idea here is just to provide that abstraction layer that allows you to basically unify how do you deal with resiliency, observability, and security concerns when accessing infrastructure. And this is quite common for all applications, right? So if you go to the website, you will see this diagram that basically shows you the top layer, which is like any language, then Dapr sitting in the middle between infrastructure and your Kubernetes clusters, your cloud providers. The idea here is your applications can talk to Dapr using APIs, and you can see that inside the blue rectangle, you can see different building blocks. Those are the APIs that are exposed. And down there, you can see observability, security, and resilience, that it's basically implemented by all the APIs. With all these APIs, you can connect to all the services that are described down there, right? You can go to cloud services, you can access PostgreSQL, you can access RabbitMQ, you can access Kafka. But from your application perspective, you only talk to an API. So we can switch to the next one. So in order to make it more simple, we decided to just create some simple examples. In this case, showing you two simple applications. Imagine two Java applications that are producing and consuming messages. And in this case, we chose RabbitMQ because we think that it's a common way of exchanging messages. You can use Kafka, you can use any other message broker. One thing that you see in this diagram is that you have the RabbitMQ client as a dependency inside your application. You need that in order to connect to the RabbitMQ cluster, so these two applications can exchange messages, right? So if you go to the next one, you will see that if you install Dapr inside your clusters, then you remove that RabbitMQ dependency and you delegate all the connection aspects to the Dapr block in this case. In Kubernetes, this is implemented using sidecars. That basically means that inside your pod where your application is running, you have another pod that exposes APIs. And in this case, these APIs will be exposed to the application to access locally. So they can do localhost / in this case, publish message APIs. And the container that it's running Dapr is exposing those APIs and connecting, in this case, to the RabbitMQ broker. So I think that it might be a good idea, Matthias, now, if you can show the application running in a Kubernetes cluster, just for people to understand a little bit more about how this works.
Okay. Can you hear the terminal?
Yep. Yep.
Perfect. I have here the kind installed. If you do not know, kind is Kubernetes in Docker, and I can access basically via kubectl get pods. I have some pods here. The first one is the consumer app. We have here PostgreSQL database, the producer application, and the RabbitMQ. Okay, let's enter. Let's see this one. Logs, just to see the consumer. It's a Quarkus application. Okay, and the producer too is a Quarkus application. One moment, my monitor is visible for me. One moment, sorry. Okay, perfect.
I think that you need.
Let's.
Yeah.
Okay.
Go for
Sorry.
it. Yeah.
I will do a port forward just to send a request to the producer application. In another terminal, I will just send a curl with a post to the URL orders using application JSON, content type, and send in keyboard and them out here. I send the message, I receive the order stored and if it's published. And if I look at the log again, let's see the producer first. Producer. Okay, publishing order event, order, keyboard, amount 199. And if we see the consumer application, we have the application consuming this event, okay? Then what happened? The producer uses the API, the Dapr API sidecar to send the item here, keyboard, and behind the scenes uses the RabbitMQ PubSub, and the consumer can now subscribe to this message and consume. Okay, basically this is our example. We can see the code later.
So, Mateus, one thing that you can show is like if you list the pods, for example.
Perfect.
If you list the pod, you will see that, yeah. So if you list the pods, you will see that, for example, the producer and the consumer both have two containers running, right? And that's kind of like the part where, Dapr is providing an extra container for the application to interact with those APIs. And if you do kubectl get components, you can see how RabbitMQ is configured. In this case, you can see that there is a PubSub component there. So if you do kubectl describe components PubSub, yeah, we can see here that basically what we are telling Dapr is, Dapr, here is like a RabbitMQ cluster that we installed inside the Kubernetes cluster. These are the connection strings for you to connect. So now if an application wants to consume or subscribe to a message, they can just use this component name instead of having to connect to the cluster directly. And then we are going to look into the code for the applications, not now, in a little bit while we introduce the Java SDK in this case.
Perfect. Let's open here.
Yeah.
One moment, this is loading. If you can run this example in your Kubernetes cluster, you can, I will share the GitHub repository for this example and basically follow these steps, okay? But let's see the code. We have here two applications, producer and consumer. Let's see the producer first. It's basically a Quarkus application with Quarkus Dapr extension. And looking the code level, we have basically order class and the order resource here. What happened here? We are injecting using the constructor, the Dapr client. Okay, by default, the Dapr extension for Quarkus injects this bin for us, and we can now use the save state API and pass in here the key store, the store name, the ID, and the object order. Okay, it's a synchronous call. Then we are using here the block to make this one sync, log in, and publish an event. Okay. I would like to show the APIs, just to the people see. We have some methods here: save state, get book state, save state, publish event, get book state, delete state. Basically, we can use secrets to configurations, get secrets, a lot of methods here. Basically, this one is the producer API, the producer side. And looking here, the consumer side, we have an order just to map the payload, and a simple resource here with path and a method post. And this is the notation used to subscribe to a topic. I am using the topic here. It's from Quarkus Dapr extension, pub/sub name, pub/sub, the name of the topic, and it can be a cloud event. We can wrap the payload with a cloud event object. And basically, I am adding the events here. It's a simple list, a URL list here. And we can use the events just to get all the events received from the producer. Basically, this is the code. I think just to show, this is Quarkus related, Quarkus container image, just to name it. This extension here is this one. Let me see here, Quarkus container image gib. It helps you to create your container image with Quarkus. And basically the registry, I'm using the registry local image group, and this is all of producer and consumer application. Let's see here just the properties from this application. It's the same. Change just the image name. I think, Salaboy, I showed all things from this application.
Yeah, so basically you're showing kind of like the application that is running inside the cluster, right? And I think that something that I wanted to say on this diagram here is that Dapr provides these APIs, and I think that when you think about APIs, usually you think about like client server, where you can only call the APIs. But in this case, Dapr is providing a bidirectional API connection with the application. So you can call the Dapr APIs, but also Dapr can call your application back, as in the case of the consumer, right? Whenever a message is published inside the topic inside RabbitMQ, Dapr gets notified, and then the application gets notified with that message to the consumer app. So I think that it's kind of interesting, right? It provides that abstraction with any broker. In this case, you can now go and change the same application to work with Kafka without changing the application code or its dependencies. You just need to change the configuration on the Dapr side. But so far, we have been talking about running the application inside the Kubernetes cluster. You need to install Dapr. You also need to install, in this case, RabbitMQ inside the cluster. And then you need to create containers, as Mateus showed. Like, you need to create the containers for the application so you can push them to the cluster. And this sounds really complicated. Next slide. So we have been working quite a bit, also like with the Quarkus extension, as well as with the Java SDK, to make sure that we provide a developer experience that doesn't require you to have a Kubernetes cluster or installing Dapr or writing a lot of YAML that probably it's not part of your application, priority. So we wanted to show you a little bit about like the local developer experience that you can use to create Dapr applications that can interact with the Dapr APIs without even thinking about Kubernetes at all. Next slide. And for that, we need to talk a little bit about the Java SDK. So the Java SDK allows you to interact with the Dapr APIs that are exposed by the Dapr sidecar using two protocols. One is gRPC and the other one is plain HTTP. But when you're building kind of like highly scalable applications, we usually recommend the gRPC way of doing things. So if you go to the next slide, you will see that the Dapr, the Dapr plain Dapr Java SDK will allow you to create this, in this case, the client using the client builder, and then just use any of the available APIs as Mateus showed before. What we have done in the Dapr extension is making sure that you don't need to create a client, that Quarkus will automatically inject that for you. Next slide. Same with other APIs. In this case, is showing the state store API. That's basically an abstraction for key value stores like Redis and other providers. The next one. And then, yes, like invoking SQL databases. And there are a bunch of other APIs that, if you are building distributed applications, you will probably need. And finally, something that I wanted to talk a little bit about, because I think that we will show something later, is the workflows or durable execution for orchestrating different services. And what we are showing here in this slide is pretty much like the Dapr workflow APIs that allows you to create orchestration across different services, again, using all the Dapr building blocks for resiliency, security, and scalability. So let's talk a little bit about Quarkus. That's your side, Mateus, right?
Okay, let's talk about Quarkus and test containers. As Mauricio Latino said, it's very complicated to run the Dapr and all components. It writes a lot of YAML and kubectl for us. And the idea here, and if you are using Quarkus, if you know Quarkus has a dev service feature where you can use test containers behind the scenes to start, by example, PostgreSQL database or Redis or RabbitMQ, Kafka, depending the extension, obviously. But for Quarkus and Dapr, when we are using the Quarkus, the Dapr extension, you have a Dapr running in a container as a sidecar. Okay. And okay, I will show this working in the dev service. But basically, Quarkus developers can use the Dapr APIs without need to use the Kubernetes cluster. Okay, and it's basically the dev services. You can just use the Quarkus dev command, and we have the Quarkus integrated with the Dapr API. It's basically what you need to do is to install the Quarkverse Dapr extension, and you can use the state management, the state store, pub/sub, publish event, and subscribe it to an event to use secrets and workflows. These workflows is in development. We are working a lot to provide this capability to work to Dapr, Quarkus Dapr. And the another one is the microprofile reactive message, because if you are using, for example, Quarkus Kafka, you know the reactive message, the microprofile specification, and we are working to provide this to Quarkus Dapr extension. Basically, you can use the Dapr client injecting via constructor or via field, and to use the Quarkus dev command to have your application running with Dapr. I think I can show the pub/sub running. Let's stop this one. Okay. We close. Perfect. I will starting the producer app and run a Quarkus dev. Just to see, we have here just the MySQL, a registry local, and I think the Kubernetes in Docker. Let's run the application. Sorry. Producer and Quarkus dev.
Mateus, I think it's important to mention here that this has nothing to do with the kind cluster that you had before, right? You can actually go and shut down the cluster, and it will not use anything related to Kubernetes.
Yeah. You don't need to do basically this one. Write a lot of YAML, KV store, producer app, PubSub. You just need to execute the Quarkus dev, and behind the scenes, the dev services for Quarkus works for you. Make your life as developer easy. Okay, let's wait. And dev service for Dapr started. I have a port here executing 19. Okay, it's a conflict.
Yeah, I think that you have the kind cluster also, like the port forward.
Yeah, close it. I have two Quarkus application running.
Yeah.
Sorry.
Oh, that's okay.
Okay, Quarkus app. Okay, let's see the Docker, and I have here those containers. I will show this command to be okay. Here we have the Dapr Dapr replacement, and Yuk by default, just buff Dapr and Dapr placement containers here. Do you like to talk about those?
So the Dapr container is the sidecar, right? So when running in Kubernetes, that's the one that gets injected right very close to your application. And then you have the Dapr placement service that basically will be used for running workflows and actors as well, which is also another API that Dapr provides. So think about that, like those services are more like the control plane for Dapr applications. That's something that gets installed when you install Dapr inside the cluster. In this case, it's all started by test containers.
Okay, I will send the same request to this application, and we have the order stored and the event published. But we don't have a consumer. Okay, it's in memory, PubSub and the state store building blocks, but we can use the Dapr with the sidecar using Quarkus and dev service. Basically, it's so easy to start coding with Dapr and Quarkus. Okay, basically, this one Celaboy said, Dapr handles the connection pool and the resilience, but no, this no. It's about the resilience because we can configure a lot of things when using Dapr.
That's correct. Yeah. So basically, when you think about, like in this case, replacing, for example, Kafka for RabbitMQ or even for a cloud provider service, right? Like you can configure today Dapr to connect to Amazon SQS, Google PubSub, Kafka, RabbitMQ, and a bunch of other different message brokers. And you might start thinking, for like the developer is just publish an event to a topic or subscribe to events in that topic. But Dapr allows you to, when you go and configure these providers, you can configure and fine-tune each specific connection and connection pool, the encryption between the broker and the applications. You can configure specific properties of Kafka in the connection that Dapr creates. So you don't lose that very specific set of features from the provider, but you expose a simplified APIs that developer can use. And then when you deploy the application into production, you can actually fine-tune that connection from Dapr to the provider for high scalability and security and observability and all the other things that you need in a production environment. And I think that takes us to something, again, that we mentioned before, which is Dapr workflows, something that we wanted to show a little bit more in action, because I think that this is becoming much more relevant nowadays with agents. When we talk about like AI agents or things that will coordinate, for example, multiple calls to different LLMs, we need to handle state, and we want to make our application resilient, right? Like we don't want to be, calling the same LLM hundreds of times because the application is crashing, for example. So with Dapr workflows, you have a programmatic way of defining how to do different calls to different systems in a durable way. And that what basically means is that if the application crashes at any point, when the application comes back, Dapr workflow will know how to resume that execution from the point it was left. So in this case, you can see a very simple orchestration, a very simple workflow that basically is trying to track a customer. So the first activity, it's called register a customer. And basically, imagine that you have a REST endpoint where the customer registers itself, and it will kickstart a new workflow instance. So you get the customer payload, you execute an activity that is something that you can define. You define the logic of what does it mean to register the customer. And the workflow will only just go and call that piece of code in this case, right? As soon as the first activity is done, the next step in this case is called wait for an external event. And that basically allows you to say, hey, I need to wait for an asynchronous event to arrive to my application. It can be a Kafka message. It can be calling a different endpoint. It can be an email, or it can be a creation of a file in a directory, right? Whenever that event arrives, then we will move the flow to the next activity. In this case, it's called customer follow-up activity, right? And then you execute any other logic that you want. As I mentioned before, if the application crashes at any point of this flow, when you start again the application, it will continue from the place it was left off. So maybe, Mateus, we can execute kind of like some of the workflows that we have.
I can. I think
you can explain.
This is in development, but I can show this one. Let's open here the workspace.
I think that this is important to mention, Mateus, that we are in active development of this extension. So if people wants to join and help, this is the perfect time for building examples and just trying to help us document the whole process.
I will share the code because I'm not sure if this code will work now.
Okay, that's all right.
Okay. But basically, not this one. Simple. Then change workflow, uppercase. Let's here. Okay, I have the workflow here that implements workflow. Basically, I am getting here the instance from context and call an activity. And this activity, we have workflow activity that basically just makes some validation here from this input and change this input to the uppercase. Basically, this one. And how can I start to trigger this workflow? Basically, using Dapr workflow client, if you are using the Dapr 2.4.0 version, this Dapr workflow client is not able to you. You need to wait for the next release. But basically, you need to use Dapr workflow client and schedule a new workflow. We got instance ID, and you can return the instance ID using the header, back sample. Let's try to start this application. I'm not sure if this one will work. If not to work, okay. But let's try this one. I will remove this because we are not using backsample. You can you can inject a REST client here if you are using Quarkus REST client, and basically you can call an application, basically call a REST client. But I will not do it because it must be very simple. Let's see here, Quarkus dev. If not to work, okay.
It's okay. It's in development.
It's okay. Right? It's development.
It's going to be ready in the next release. So
I can show to you the pull request. We are having an issue with the compilation, native compilation.
Yep.
Let's wait the start. Okay, Dapr running. Oh no.
Something failed.
Application. Recorded being demo channel workflow. Okay, I need to use this one.
You need to use the application scope. Yep.
Yeah. Let's try again.
So just for people to understand, basically, we are defining workflows as beans in this case, right? Like they are like application scope beans, and both workflows and activities are kind of like application wide. So they need to get registered with the Dapr sidecar. And by just annotating these classes, we are automatically registering these workflows there.
And not to worry,
So things really.
sorry a lot.
Oh,
But
no
okay.
worries, no worries.
Yeah.
Yeah.
No worries. Okay.
But what we can mention here is the idea is that as a developer, like if you show the application, right, like the REST endpoint, so you have like the workflow definition that are basically the classes that define the logic of the orchestration that you want to execute. And then you have the endpoint that basically uses the Dapr workflow client to just start new instances of those workflows. And you can also show kind of like the Dapr workflow client like raise event, right? So in order to raise asynchronous events, you have another API to do that as well. Right.
Perfect. Let's show the pull request here. One moment, just not about the workflow, but the reactive message too. You can use, for example, if you want to use the message Dapper. I created example just to see how this one will assumes in the future when we release a new version. It's loading.
It's
While
GitHub
this
is
one is
slow.
loading, let's skip this one. Let's
Yeah.
wait this one loading. Okay.
That's good. That's good.
Go ahead. Go ahead.
So I think that like, the only thing that I wanted to mention in that slide is that you can basically use all the things that you can use in any Quarkus, class or bean inside Dapr, and you can just make that integration with your workflows in a very simplified way. That's pretty much what the pull request has, the mechanisms to basically bring the Dapr APIs closer to the Quarkus programming model. And I think that that's extremely important to make sure that Quarkus developers, they don't need to learn about like how Dapr works. They just can use and keep coding their applications in the same ways that they are already used to. But in this case, just having two new clients, the workflow client and the Dapr API client, just to call the Dapr APIs. All the rest, like starting Dapr, making sure that the containers are started, that the infrastructure is configured, is done behind the covers for the developer. I think you can go to the next one. And of course, like depending on the scenario that you're implementing, we have a lot of examples in the Dapr SDK about like different patterns that you can implement. In this case, it's like parallel tasks, right? So if you look into this code, it's a very native Java experience of creating parallel tasks and then waiting for all of them to complete in order to move to the next activity. Right, like this, when you look at this code, besides the call activity line that is basically calling a specific activity or a specific task, all the rest is just pure Java primitives, right? We're iterating over a collection, just calling activities in parallel, and then at the end, we wait for all of them to complete before to move forward. The next one is another pattern, basically that it's not called parallel task, but it's more about child workflows, right? This is all about like composing multiple workflow layers, right? You want to, when you are creating workflows or complex orchestrations, you want to create building blocks that you can reuse, so you don't repeat or duplicate code, right? And in this case, basically what we are showing is that one workflow definition can call other workflows that are considered child workflows. So the parent workflow will wait for all the activities inside the child workflow to complete before moving forward. And these are just basically the main building blocks that you have to construct these orchestrations that are durable, that are secure. And if something fails, Dapr workflow will keep retrying. You can configure how many times these retries will happen for your workflow. And then you can define the logic to about like what happens when something goes wrong. How do I recover from that? Like executing compensations or implementing more complex patterns like the Saga pattern, for example. I think you can go to the next one. And that's another pattern as well. I think that we can skip this one. This is just how do you make sure that you do consistent scheduling, right? Like timers that happens, at a very specific time, like every Monday at 9 a.m. I want to run something, and then I just want to schedule something for next Monday, right? That kind of stuff is very useful. You can go to the next one. So at the end of the day, I think that what we show in this presentation is like two things. Like on one side, we talk a little bit about the Dapr project. That is something that you use on Kubernetes. But then on the second half, we talk a little bit about more how you can use it from Quarkus. And Mateus here has been fundamental in creating that Quarkus experience because he's now the Quarkus extension maintainer, and he's actively improving how Quarkus developer can access to the Dapr APIs. So those two sides is like, okay, if you are into the Kubernetes world, you need to understand how Dapr works for running applications in production and to configure that with complex infrastructure. But if you're a developer and you're using Quarkus, your life should be simple. So we should start Dapr for you, we should configure the APIs for you, and we should give you the APIs in a simple way that you can consume. Mateus, do you want to add some notes?
Yeah, I would like to share the project link with the chat. One moment. Let's open here. This is the Quarkus Dapr extension repository. But basically, this one is an extension, Quarkus extension. My internet is not good now, but okay. Feel free to test the Quarkus Dapr extension, to use the state management, input binding, or secrets published and subscribed by building blocks. We have some examples here. And feel free to open an issue, to get an issue to work. We need volunteers and new contributors to our project. And I would like to share too the Java SDK Dapr. Basically, I think you are a Java developer and you can contribute with this project too. Basically, Java SDK Dapr. I will share this one too in the chat. One moment. Java SDK. Okay. Send. And Quarkus Dapr repository. I think this is my comment. And thanks. Thanks for all.
Thank you so much, folks, for the attention.
We have questions. I don't know. If you have a question, please type in the chat.
We are looking into the chat.
I have some questions. Can I do some?
Go for it. Yes.
Go
ahead. Do we have in Dapr? Do we have a centralized console, something like that, to control all the things that are going on in Dapr's infrastructure?
So we have something that it's called Dapr Dashboard that basically gives you kind of like the visibility on the components that are configured for your applications to use. As a company, we are building a product that basically will help you to run Dapr at scale. So if you're running, like 10 clusters with Dapr installed in those 10 clusters, you need a centralized tool to manage all of those. You can check the Diagrid website for that if you're interested in that. But community-wise, what people usually do is they rely on things like, open telemetry for understanding the interactions between the applications and infrastructure. And what Dapr does is brings kind of like another layer on top of my applications are using, for example, RabbitMQ, or they're using this state store to do this very specific thing. So you can get more like an application view on how infrastructure is used that you usually don't get by just looking at, at the drivers from or the clients for RabbitMQ or from Kafka. So yeah, you can check the Dapr dashboard. That's the community project. I think that there are chances that at the end of the year, we have another dashboard as well that will be community driven, but it hasn't been announced yet.
That's great.
I think that it's important also to mention that as a Kubernetes user, you can explore all these connections with any Kubernetes tool because they are like all these resources that you use to configure Dapr itself. And all the things that Dapr uses to connect things are just CRDs or Kubernetes resources. That's why, for example, you can do kubectl and get, the components that are being configured for your applications to use.
Great. And do in talking as I have a Dapr as a layer between my message broker and the application. Do we have some point in which I can customize, for example, for some Kafka parameters, I have some Kafka that is different from RabbitMQ.
Yeah, exactly. Yeah. So I can find the link here. Pops up. There are tons of different implementations for the APIs, and each implementation will have its own parameters that you can configure, right? Because the parameters in Kafka are not the same of the parameters in RabbitMQ, right? And you want to configure, Kafka specific features. Yeah. So you can see in the link that, yeah, exactly.
This one?
Yep, that one. Okay. So you can see that you can configure. Like, first of all, you can see all the. I've shared the link of all the available implementations, and then you have like all the parameters for each implementation. So all the timeouts, all the heartbeats, all the retry mechanisms that are implemented inside Kafka or any other broker.
No, that's great.
So that's the idea, and you can do the same with the other APIs as well.
That's great. Thanks.
No worries.
For platform engineer, did you share?
No, I couldn't share the message in the chat, but that's all right. Let me see if I can share it in the private one.
Yeah.
Yeah, in the private one. That's it.
Just one.
Yeah, that one basically shows the list of all the implementations. You can see you have Kafka, JetStream, KubeMQ, MQTT3, Pulsar, RabbitMQ, Redis Streams, RocketMQ. Yeah, and that's kind of like the generic ones. We call it generic, but those are the ones that are not cloud provider services. So if you scroll down, you can see that you have the Amazon one, the Azure one, and the Google Cloud one as well. Yeah. So the same API for all the services, you can configure them then on the Kubernetes side, let's say. For development purposes, you actually don't care which one you are using, right? As an application developer, you are interested in publishing or consuming messages.
It's for our platform engineer. It's a great tool.
Yep.
Okay, I think we don't have...
Matheus, aquele ambiente que você rodou localmente, o ambiente local, o Dapr subiu como um dev service lá para você poder rodar localmente, ou simplesmente ou você só referenciou? A única coisa que precisou fazer foi referenciar lá no POM aquela.
O primeiro.
Não, o primeiro, o segundo, foi... era aquele lance de mostrar rodando localmente, sem o Dapr, sem o Kubernetes. É só referenciar
com dev service, né? Isso.
E aí ele sobe o dev service, né?
Isso.
I was asking if what we have to do to run the Dapr environment in locally.
You don't need to do much, right? Like just have the Quarkus extension. I think that you have dev services there.
Very easy.
You just need to run the Quarkus dev. I will share again the POM XML. And we need to add this extension, Quarkus Dapr. By default, the Quarkus Dapr dev services enabled is true. Dapr dev services enabled equal true by default. And if you want to disable this one, this is false. It's just run Quarkus dev and you have Dapr and your application running.
Yep.
Great. That's cool.
Good stuff, guys.
Let's close. Okay.
Great.
Okay.
Great.
Thank you so much for having us, Luis.
Thank you for sharing.
Thanks all.
Good luck with the Quarkus extensions and the Dapr development. I will go to check it out.
Thank you so much.
Thank
Highly
you. Bye-bye.
appreciate it.
Bye bye. Bye
Take
bye.
care, folks.